Today, I will be presenting on Build to Move, the musculoskeletal system. The musculoskeletal system is one of the most important systems in the human body. It allows us to move, maintain posture, and also to stay stable. It also supports daily activities like walking, lifting objects, and even maintaining balance while standing. This system is made up of bones, muscles, and joints. All of these work together as one single functional unit. When any part of this system is affected, movement becomes limited and the quality of life can be reduced. In this presentation, I will briefly explain the anatomy, function of the musculoskeletal system, focus on how movement occurs through muscle contraction, discuss osteoarthritis as an example of disease, and also highlight the contribution of Sir John Charlie. The musculoskeletal system enables movement, posture, and stability. So what is it? There are three components of the musculoskeletal system: bones, muscles, and joints. Bones provide a rigid framework that supports the body and protects vital organs. Muscles attach to bones and generate force, while joints connect bones and allow flexibility and smooth movement. All these components must work together in a coordinated way. For example, without muscles, bones cannot move, and without joints, movement would be very limited. Therefore, the musculoskeletal system is very important not only for movement but also to perform everyday activities and maintaining independence. Let's move on to the anatomy of the musculoskeletal system. Looking at the anatomy, the musculoskeletal system consists of muscles, bones, and joints. Skeletal muscles are voluntary muscles, meaning they are under conscious control. They generate movement by contracting and pulling on bones. Bones support the body. They protect organs like the brain and heart. They store minerals like calcium and phosphate. All these are important for bone strength. Joints connect bones and they allow flexibility. Synovial joints like the knee and hip are especially important because they allow a wide range of movement while reducing friction between the bones. Together, these structures form a system that is both strong and flexible. Let's move on to the physiology of the musculoskeletal system, focusing mainly on the sliding filament theory. Now, I will explain how movement occurs. Muscle contraction takes place in a structure called the sarcomere, which is the functional unit of one muscle fiber. Inside the sarcomere, there are two main proteins known as actin and myosin. Actin forms the thin filament, while myosin forms the thick filament. When a nerve impulse reaches the muscle fiber, calcium ions are released from the sarcoplasmic reticulum into the muscle cell. This increases the intracellular calcium that is essential for muscle contraction. Calcium then binds to a protein called troponin. This causes another protein known as tropomyosin to move away from the binding sites on actin. This exposes the sites where myosin can attach. Myosin heads then form cross bridges with actin. Using energy from ATP, the myosin head pulls the actin filaments toward the center of sarcomere. This action is also known as the power stroke. As a result, the sarcomere shortens, but the actin and myosin filaments themselves do not change length. Instead, they just slide past each other, which is why this mechanism is called the sliding filament theory. This process continues as long as calcium and ATP are present. When calcium is pumped back into the sarcoplasmic reticulum, the muscle relaxes. In addition to muscle contraction, bones also play an active role through bone remodeling. Osteoblasts are immature bone cells. They build new bone osteoclast break down old bone. This process allows bones to adapt to mechanical stress and also maintain bone strength. Now, we will jump to the disease of the musculoskeletal system. Osteoarthritis is the most common degenerative joint disease and is also a major cause of pain and disability, especially among older adults. This occurs due to the breakdown of articular cartilage, which normally acts as a shock absorber and allows smooth movements of the joint. As cartilage wears away, bones begin to rub against each other, leading to pain, stiffness, and also reduced mobility. Osteoarthritis commonly affects weight-bearing joints like the knees and hip as well as the spine. Over time, these changes significantly affect a person's ability to perform daily activities. We will now look at the management of this disease. The management of osteoarthritis focuses on relieving pain and also improving joint function. The first-line treatment includes exercise and weight control. This helps reduce stress on joints. There are pain relief medications that are used, while surgery is considered in severe cases. There are modern advances such as 3D printed implants, tissue engineering, and robotic assisted surgery. These have greatly improved the treatment outcomes. One of the most important contributors to osteoarthritis treatment was Sir John Charlie. He was the pioneer of modern total hip replacement, and he also developed low-friction arthroplasty. His work revolutionized the treatment of hip osteoarthritis and also laid the foundation for modern joint replacement surgery. As a conclusion, the musculoskeletal system is essential for movement, stability, and also daily function. Understanding how muscles contract and how joints are affected by disease helps us appreciate the complexity of this system. Osteoarthritis remains as a major clinical and public health concern, but advances in medical technology continues to improve patient outcomes. Overall, this topic highlights the importance of maintaining musculoskeletal health and the role of innovation in modern medicine. Thank you.